All right, Longhorns, in this set of notes, we're going to look at the graph of an equation and the set of all points that are on the graph are solutions to the equation. So we're going to look at some equations and we're going to determine if the point that we've been given is actually a solution or not. So I'm going to go ahead and expand this page so that we can take a closer look at the first example. We're going to look at example 1, question A first. So in this first question, we are to determine if the given point is a solution for the given equation. So the way we're going to do this is we're going to label our point x, y, and we're going to substitute those values into the equation. And if the equation is true, then that point is on our graph. Okay, so here you can see that I have substituted this y value right here of 13 in for y in my equation. That's right here. And I've substituted this for x into my equation right here for x. And there's that substitution. Now what I'm going to do is I'm going to simplify this, and I want to see if this equals 13. Okay, so I have determined that 13 equals 20 minus 7, and 20 minus 7 is 13, so 13 equals 13. So indeed, this point is a solution, or this point is a point on my graph. Okay, in the next example, I'm going to do the same thing. I'm going to substitute my x and y into my equation. But the one thing I want you to notice here is the numbers for x and y in this case are negative numbers. Do you remember what I told you about negative numbers and substitution? I hope you remembered. All right, so I have substituted this negative 3, my y value, in here, and this negative 1 in here, and notice that I put it in parentheses before I squared it. That is so important. You have to do that. If you put this negative 1 in without the parentheses and you square it, you're going to get negative 1, and that is not the correct answer, because a negative 1 times a negative 1 is a positive 1, not a negative 1. So what we end up with is that negative 3 is equal to 1 minus 1, or negative 3 equals to 0. And we know that negative 3 does not equal 0. Those are not the same numbers. So in this case, this point, negative 1, negative 3, is not on my graph, and it is not a solution. Now in the next example, we're going to sketch a graph of y equals x squared minus 2 by creating a table. So we're going to create the table, and then we're going to sketch the graph. So I'm going to go ahead and expand that so we can see, have a better picture of what's going on. All right, so this is the table I've created. Normally we use a t-table with just x and y, but I included another column in the middle. That's going to be our process column. And I think it's real important for this particular graph because I want to make sure that when you're entering these negative numbers into your calculator, or if you're just doing it by hand, that you're remembering to put that negative 2 in parentheses. Very important when you're squaring a negative. All right, so I've put all of the processes into the process column, and now I'm just going to finish these calculations to find out what my y values are going to be. All right, now that I have my table completed, I can go ahead and graph my points. So the points I'm going to be graphing are this value for x and this value for y. All right, so I've graphed these points. Negative 2, 2, negative 1, 0, negative 2, 1, negative 1, and 2, 2. And this particular graph we created is called a parabola, and it's in our family function of quadratics. All right, so in this next section of the notes, it says Make sure you have enough points before you guess what the graph looks like. Because sometimes we're going to graph some points and then we have to determine what function is that. Is it a quadratic? Is it absolute value? Is it a cubic? What kind of shape do our points make? What kind of graph is that? So sometimes if you don't have enough points, you really can't tell what the shape is. So what we're going to do is we're going to graph these points, and then we're going to take a look at our graph, and we're going to determine if that's enough points to tell what shape the graph is. All right, so here I've plotted the points, negative 2, 2, negative 1, negative 1, 1, negative 1, and 2, 2. Now you might think, well, that looks like it could be a quadratic, but we're not really sure. It could be really anything. We don't have enough points. So really what we need is some more points, because this could actually be a graph that goes, maybe it goes like this, straight across and up. Or maybe it is a quadratic. Maybe it goes down like this, like our first graph. Or maybe it's like this. This would be an absolute value graph. So there's really not enough points. We really need at least one more point, maybe even more points to determine specifically the shape of this graph. All right, so the next thing we're going to look at is determining the intercepts of the graph. The intercepts of the graph are where the graph crosses either the x or the y-axis, depending on which intercept you're looking for. X-intercepts, we let the y value equal 0, and we solve for x to find the x-intercepts. That's where the graph will cross the x-axis. And then we do the opposite for the y-intercepts. We let x equal 0, and we solve for y. And that gives us the intercepts on the y-axis. So the x-intercepts are going to be points x, 0, and the y-intercepts are going to be points 0, y. So in this first example, we have to find the x and y-intercepts of this graph, x to the third power minus 4x. So we're going to have to do this by factoring. So one of the things that you're going to have to remember how to do for Precal is something that you learned how to do in Algebra 2, and that was factoring. All right, so let's start with the tough one. Let's do the x-intercept first. All right, so to find the x-intercept, we have to make y 0. So we're going to make y 0, and we are going to solve for x. Now, the first thing we're going to have to do is factor. We can, since both of these terms have an x in them, we can factor out an x. So we're going to have 0 equals x. We're factoring it out. Do you remember what factoring out means? It means we're going to divide it out. So I'm going to divide each one of these terms by an x. So if I divide x to the third by x, I have x squared left. And if I divide 4x by x, I'm left with 4. All right, well, I'm not done factoring yet because I can still factor what's inside the parentheses. And if you remember from Algebra 2, if you have a square subtracting another square, that's called the difference of two squares. And those always factor the same way. It's the square root of the first minus the square root of the second times the square root of the first plus the square root of the second. And this one will look like this. 0 equals, now we have our x on the outside, that stays there. But this difference of two squares is going to make two binomials. We're going to have our x times x, and then here we're going to have a minus 2 and a plus 2. And that's how that one factors. Now what we need to do is we need to find all the what we call zeros. Okay, so we want to find out where this graph crosses the x-axis. Where are all the zeros? All right, so if I set this equal to 0, which is what I did, If x is 0, then that's going to be one of my solutions. So x equals 0 is one of the solutions for x. Then I need to also find the solution for this one. X minus 2 equals 0. What's that solution going to be? Well, if I add 2 to both sides, I get x equals 2. So that's another one of my solutions, is that x is 2. Then I do the last one, x plus 2 equals 0. Now I have to subtract 2 from both sides. And I get x equals a negative 2. All right, so I've got 3 x-intercepts. All right, one of them is 0, 0. Another one is 2, 0. And the last one is negative 2, 0. So that's all the x-intercepts for my function. Now I need to find the y-intercept. Now to find the y-intercept, I'm going to make x 0 and solve for y. All right, so here I have y equals, and I substituted a 0 in for x here and here. So I get y equals 0 to the third minus 4 times 0. Well, this is just 0 minus 0, so we just end up with y equals 0. So my y-intercept is 0, 0. Now you probably noticed that you've got a y-intercept of 0, 0 and an x-intercept of 0, 0. That is the only place on the graph where your x and y intercept are the same point. That's called the origin. And that's the only place on your Cartesian plane where you're going to have an x and a y-intercept that's exactly the same point. Okay, so the next thing we're going to talk about is symmetry of a graph. So we have basically 3 different kinds of symmetry, and not all of the symmetries are functions, however. The 2 graphs that you're looking at right now on your notes, those are both functions. And this first graph right here, this graph is symmetric about the origin. That means that this side right here is a reflection of what you have over here on this side. If you were to fold your graph in half along this dotted line, it's called the y equals x line. If you folded your graph on that line, then you would have a symmetric graph. And that's symmetric about the origin. And we say that those kinds of graphs are odd. This other graph over here, this one is symmetric about the y-axis. And when we have graphs that are symmetric about the y-axis, that means that if I folded my graph in half right here along the y-axis, that it would be symmetric about the y. That means that this side would be exactly the same as this side. And we say that that graph is an even function. The other kind of symmetry that is not shown here is when the graph is symmetric about the x-axis, and when that happens, that is not a function. So do you know why it's not a function? All right, also, some graphs might not have any symmetry at all. So just because it's a graph doesn't necessarily mean that it's symmetric. All right, so the next thing we're going to look at is types of symmetry. And we talked about it a little bit, but now we're going to go ahead and look at how we test to see if a graph is symmetrical or not. And so in problem number 1, we have symmetry with respect to the x-axis. I just talked about that. So we know that if a graph is symmetric with respect to the x-axis, it's not a function. So let's take a look and see what happens here. All right, so let's take a look at this right here, what we've done. We have for any point x, y, x minus y squared equals 1. And for any point x negative y, x minus a negative y squared is also 1. So why is that? Well, a negative y times a negative y is positive y squared. So we end up with x minus y squared again. So you end up with the same number again. So these two numbers are actually the same number. So that is why we end up with this symmetry. Now this one is symmetric about the x-axis. That means that I have y values above and below the x-axis at the same value for x. So that should give you a clue right there that that's not a function because it does not pass the vertical line test. All right, in the next example, we're replacing x with negative x. And what we want to find out is, well, do we end up with the same equation? And the answer is yes. In this case, we have symmetry about the y-axis because we have the same value for x on both sides of the y-axis for that value for y. So in this case, the plus 3 doesn't really change the symmetry. It's still symmetric about the y-axis. All right, so in our third case, we have symmetry with respect to the origin. So in this case, for any point x, y that's on the graph, there's a point negative x, negative y that's also on the graph. So if that happens, then you know that your graph is symmetric with respect to the origin. All right, so if I have a y and an x, and I change those values to negative y, negative x, this is how I can test to see if my graph is symmetric with the origin. And you can see right here with the equation here, I replaced y with negative y, and I replaced x with negative x. And what I end up with is negative y equals, and this ends up being negative x to the third, because negative x times negative x times negative x. So you have a negative times a negative, which is a positive, times another negative, which keeps it negative. So then in this case, we have a negative x to the third. So here I have a point, negative x, negative y, that's also on my graph. And because this happens, this particular graph is symmetric to the origin. All right, so in the next example, we're going to test for symmetry in each one of these cases. So first of all, we're going to do test 1, which is with respect to the x-axis. So remember, if it is symmetric with respect to the x-axis, I should be able to replace y with negative y and still come out with the same answer. If not, then it's not symmetric to the x-axis. All right, so we tried test 1, and I've replaced y with negative y, and right away I can see that there's no way that I'm going to get a negative number out of this x to the fourth minus x squared plus 3. That's going to be a positive number. So in this case, this is not symmetric with respect to the x-axis. So now we're going to try test 2. Okay, so in our test 2, we're testing to see if the function is symmetric with respect to the y-axis. And so in this case, we are going to substitute a negative x for x into our equation and see if the result is the same. So what I did right here was I went ahead and I substituted this negative x in here and this negative x in here. And yes, if I multiply negative x times itself 4 times, I'm going to get x to the 4th power. And the same thing here, if I multiply negative x times itself, I'm going to get x squared. So this ends up being the exact same equation that we started with. So in this case, this function is symmetric with respect to the y-axis. So the one thing that you need to remember about symmetry is, once you find the symmetry of your graph, that's it. You don't have to do any more tests. This is not going to be symmetric about the origin because we already know that it's symmetric about the y-axis. Now we could do the third test and check for symmetry about the origin, but we're going to find that we're going to get the same result that we got up here. So this is not, we're still going to get a no answer for symmetric about the origin. You can only have one kind of symmetry if you have symmetry at all. All right, so the last test we're going to do is to test to see if our function is even, odd, or neither. So generally, if the graph reflects over the y-axis or is symmetric with the y-axis, that graph is even. If it's symmetric about the origin, the graph is odd in general. But sometimes we have to determine whether a graph is even or odd based on some algebraic manipulation. So what we're going to do now is we're going to do some tests for even or odd or neither on some functions that we've been given. And so if you look at this little box here, it says test for even and odd functions. It tells you what to do to check if it's even or odd. Now if it's not even and it's not odd, then it's going to be neither. All right, so we're doing the even test on this function, and if we substitute a negative x in for x into our equation, we get g of x equals negative x cubed minus a negative x. So when we simplify that, we get a negative x cubed plus x, which is not what we originally started with. We started with x cubed minus x. So in this case, our function is not even. So the next thing we're going to do is test to see if it's odd. Okay, so we're doing the test for odd, and I've substituted the negative g of x and the negative x into my function to see if I get a statement that is true, and I did. Negative g of x equals negative x to the third plus x. Another way to look at that is to multiply both sides of my original function by a -1 to make my y negative and my x negative. In this case, I end up with the same function you can see here, because I end up with a negative g of x, right here, negative g of x, and then here this negative sign in front of my function, that changes all the signs. So this becomes a negative x to the third, and this becomes a positive x. So in this case, my function is odd. Okay, in the next example, we have x squared plus 1. So what we're going to do is we're going to check to see if this is an even function by substituting a negative x in for x and see if we get the same equation back. Okay, in this case we did. So h of negative x, if I plug a negative x in for x and I simplify my equation, I still get x squared plus 1. So this particular function is an even function. Now let's test the third one and see if this one is even, odd, or neither. Okay, so I tested for even, and I substituted the negative x in for my x, and what happens here is I end up with a negative x to the third, and that is not the same as x to the third. So because these are not the same, then this is not even. Next, I'm going to check to see if it's odd. Okay, so this one's a little tricky, but it's also not odd. So what happens here is if I were to multiply my function right here, if I were to multiply everything by a -1, if this was an odd function, this would end up being negative x to the third plus 6. So that can't happen. And so since we can't have this ending up being a positive 6, we end up with negative x to the third minus 6. And this is not the same as this. So it's not odd. So this one is not even, it's not odd, so it's neither. All right, so your assignment is going to be to finish the worksheet, problems 1 through 9. We'll be working on these in class together, and this assignment is going to be due on Friday. It's going to be your first daily grade besides your notes grade. So the way you're going to get a grade for your notes is you're going to take a picture of your notes. You're going to save that picture to a PDF file, and you're going to upload that PDF file either to Canvas or to an email to me. Make sure that you have your name in ink at the top of your notes, because if I get several copies of the same notes and the same handwriting from several different students, everybody that turned in that same copy of notes is going to get a 0. So please, please, please make sure that you are taking your own notes. You have your name at the top of the page of each page of your notes in ink, and that you are mailing me your notes and your notes only.